I have basically using binomial expansion and some stuff with factorials and the binomial theorem as well.
Okay, hold on a second. Let me make sure I hit on binomial expansion. That's one that I don't keep memorized. Okay. So the binomial theorem?
Yeah.
Okay. What kind of problems do you have?
Well, so first, I don't really understand what the factorials are and just like how to simplify it. So I just have a couple of problems.
Okay.
So the first one is 6 factorial over 4 factorial.
Okay.
And it just wants you to, it just says simplify without using your calculator.
Uh-huh. That's what 6 factorial means.
Okay.
This is what 4 factorial means. That crosses out with that, and I get 30.
Okay. Okay.
And it's pretty much like that. You end up doing a lot of ratios with factorials, but if I had 9 factorial divided by 7 factorial, that's going to be 9 times 8. Because everything from the 7 down gets crossed out by this 7.
Oh, okay. So like 100 over 99 factorial, that would just be 100?
Uh-huh. Now, factorials are very interesting. What would you think, without using a calculator, what would you think that would be? Any idea, approximately? That's 50 times 49 times 48 times 47, all the way down to 1.
I don't know.
10 to the 64th power. That is more than the number of molecules in the universe. Believe it or not. It's a very, very strange thing. It doesn't seem like it should be that big of a number, but it is. And in fact, if you take a normal calculator and you do 100 factorial, it'll sneeze. It'll cough on you. It's such a big number. But anyway, so what kind of other problems do you have?
Let's see, just like another similar one is n factorial over n minus 1 factorial.
Okay. Notice that if we pick numbers to see what this would be, let's start with a 7 factorial. Well, this would be 6 factorial. So the answer would be 7 or n.
Oh, okay.
And that is a bit unusual. You kind of have to work with these a little bit before you understand this. The best way to do it is to pick some numbers if you're not sure. And it would be n regardless of what n you pick. Okay, what else? So you've had combinations and permutations? Or not yet?
We were working a little bit on combinations.
You must have had that.
And then, but then let's see, another thing I don't understand. Okay, so here I have another one that's like factorial, but there's like more to it. So it's n choose r.
N choose r means n factorial divided by n minus r factorial times r factorial. And the way I memorize this is you always know that that goes in the numerator. And I know the denominator has 2 terms. And I know there's 2 n's and 2 r's. In other words, have you learned the pick yet?
No.
Okay, well this one's very close. This one is n factorial over n minus r factorial. That's the permutation formula. And this one's very similar. We have that much of it, but it's multiplied also by r factorial.
Yeah.
And if I ever forget, sometimes I couldn't remember whether that was n or r. Like I said, there's two n's and two r's in it. So that has to be r factorial.
Okay.
And an example, go ahead.
So like, is another way of writing that, like as a fraction but without the line or whatever, like n over r?
No.
You like, oh, okay, well then maybe that's not what this is, because
If you had something like 6 choose 4, or how to choose 4 ways out of 6 possible ways, then that's going to be 6 factorial divided by 6 minus 4, 2 factorial times r, which is 4 factorial. And notice that this becomes 6, that becomes 6 times 5, which is 30, but also divided by 2, so it's 15.
okay.
And this is used in a lot of combination and permutation problems, probability problems, but also as the coefficients of the binomial theorem. In other words, when you expand a binomial, it turns out that if it's a big expansion, like a plus b to the 6th power, you can figure out all of the coefficients from these calculations. This turns out to be the coefficient of each term.
And so then, and you know how in like the binomial...
Oh, I see. I'm looking in my book now, and now I see what you're talking about. There is another way of writing that.
okay,
Only
yeah,
it's not written like, it's not like that. It's like that. In
yeah,
other words, that means the same thing as n choose r.
Okay.
Okay? Yeah, I just took a peek at my book and I saw that's what they were using in the book also.
Yeah, they just kind of switch around.
Uh-huh.
Alright, so let's see. So, just one example problem for this.
Okay.
It just says use the formula n choose r equals, equals n factorial over r factorial times n minus r factorial.
That's what I was saying. Uh-huh. Okay.
Oh, okay, yeah. And then it says use this to evaluate n choose 2, or, oh, sorry, a choose 2.
Okay, let's plug it in. What is it?
So it would be a factorial over 2 factorial times 8 minus 2 factorial.
Which is 6. Mm-hmm.
Okay, yeah.
And then evaluate this.
It would be, let's see.
Evaluate the big part first, because that's where you can cancel the most. In other words, you can cancel everything from 6 down with this 6 factorial. So 8 factorial over 6 factorial is 8 times 7. But then we have the other 2, so we have to divide by 2.
Okay, so 20.
Uh-huh.
Alright.
And this is very common. Obviously, you're going to have to do a lot of evaluations on that. Given what this formula is up here, you're always going to have 2 terms in the denominator and 1 in the numerator, at least when you're doing combination type problems. Well, anytime you're evaluating that, I guess, including the binomial theorem expansion.
And then it also just wanted you to explain the results using Pascal's triangle. So I understand the triangle, but I don't understand how it corresponds with the and choose our formula thing.
Okay. All right. Pascal's triangle is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and let me just write one more. Okay. If you compute, let's see here. These coefficients, does it have to be Pascal's triangle? Because Pascal's triangle ends up being the coefficients of a plus b to the 0th power equals that. A plus b to the 1 power gives you these two coefficients. A plus b to the 2 power gives you these three coefficients. Okay? So, Pascal's triangle is very much related to a binomial expansion. A plus b cubed is going to give you these coefficients. Now, it turns out that those coefficients are also equal to, in the first case, n choose 0. So this one, let me write as n like that. The second coefficient is, hold on a second, make sure I'm doing this right. N choose 1. Prove that. Alright. You know what? Let's, if you will allow me, let's talk about the binomial theorem and then we can relate it back to the Pascal's triangle.
Okay.
I understand it for the binomial theorem, and it definitely relates to these coefficients, but let's write what the binomial theorem is. A plus b to the nth power is equal to n choose 0 is the first coefficient times the a to the nth, plus n choose 1 times a to the n minus 1 times b, plus dot 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 n choose r times a to the n minus r, b to the r, dot 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 plus n choose n times b to the nth.
And wait, what is R?
R is, good question, hold on. R is the, hold on a moment. let's do an example, and maybe that can explain it better. I don't get a whole lot of experience explaining this. Okay, so if I expanded a plus b to the fourth, the first term is going to be 4, choose 0. Well, notice that that is 1. You with me? Okay, and an a to the 1, a to the fourth power. And then the next term is going to be n choose 1, 4 choose 1, a cubed, b to the 1. The next term is 4 choose 2, so r is counting from 0 up. A squared, b squared, plus 4 choose 3, a cube, or a1, b cubed, finally plus 4 choose 4, just b to the fourth. Okay, so notice how this works. Notice how I did a plus b to the fourth using that. Make sure you can follow what I did here. In other words, n was 4, so it was 4 choose 0 as the first term. Then it was n choose 1 as the coefficient of the second term. Well, 4 choose 1 is 4 factorial divided by 3 factorial times 1 factorial. That's the number 4. So these coefficients end up being the same as Pascal's triangle. 1, 4, 6, 4, and 1. Notice that that is the fifth row of Pascal's triangle. If it was a plus b to the third, I go up 1 row, and here's going to be your 4 coefficients of the resultant expanded binomial. So Pascal's triangle, each row of Pascal's triangle is, well, the first row is n choose 0. Aha, it's the exponent. So the first row is, why am I having a hard time making this leap? Maybe you're not. Maybe you're seeing it, and it's just me that I can't see it. But you can see that if you expanded that to the 0th power, there would be only one term, and it would be 1. Because anything to the 0th power is 1. If you expand it to the first power, it's just a plus b, 1 and 1, for your 2 coefficients. To the second power, well, this number is 2 choose 0. This number is 2 choose 1, and this number is 2 choose 2. Okay, now I got it. So this one is 2 choose 0. This number is 2 choose 1, and this number is 2 choose 2. Notice that 2 choose 2 is the same as 2 choose 0. They're both 1. Okay? To do the third level, the first term is going to be 3 choose 0. The second is going to be 3 choose 1, which is the number 3. And the third is 3 choose 2, which is also the number 3. And the fourth is 3 choose 3, which is the number 1. Notice why 3 choose 0 is the same as 3 choose 3, because it's 3 factorial over 3 factorial. Either one of them is 3 factorial over 3 factorial. This first one is also 0 factorial, and by definition 0 factorial is equal to 1, which is which is quite strange, but it is, and it's so that's why this is kind of strange, and why also 3 choose 1 is the same as 3 choose 2. They both are the number 3. And this was the expansion of a plus b to the third. So notice what we're looking at here. This is n choose 0, n choose 1 in both rows, all rows. In other words, this third row here uses that for n. The fourth row would use 3 for n. And what the binomial expansion says, no matter what n is, the very first coefficient is going to be n choose 0. The very next coefficient is going to be n choose 1, and then n choose 2, all the way up to n choose r. And finally, all the way up to n choose n.
So I'm still confused on the n choose r and the n choose n thing. I don't know what r is.
Well, this is the final term in a binomial expansion. Notice what the final term here is. 4 choose r. Well, that's 4 choose 4. That's n choose n. And that was n, was 4. Okay, so starting from the back, that's the last term. Where'd that 6 come? Oh, I wrote those in. Yeah, that's a little confusing. Those are what those numbers are. But when we look at the binomial expansion, this last term here, I had to write it below because I ran out of room, is this other term that I have circled. Okay? Notice there's no a there. You run out of a. A disappears. The coefficient on a goes 4, 3, 2, 1, 0. Just like the coefficient on b goes 0, 1, 2, 3, 4. So let's take an example where I wanted to do a times b to the 16th. What's this first coefficient going to be?
16 choose 0.
Okay. A what?
A to the 16th.
Right. What's the next coefficient going to be? Don't worry, I won't go through all of them. I just want to make sure you know the first couple.
16 choose 1. And then
A to the what?
The 15 and B, just B to the first.
Right. Okay. So you might get a question like, what is the coefficient of the third term when you expand a plus b to the 16th? Well, the coefficient of the third term is going to be 16 choose 2, which is 16 factorial over 14 factorial 2 factorial, which is 16 times 15 divided by 2. So it's 8 times 15, that'd be 120. So this coefficient is 120 if you're expanding two variables that don't have a coefficient already. Okay, so it's relatively easy if we're expanding a plus b. Where it becomes tougher to figure out the coefficient is if you're expanding something like 2x minus y squared to the 4th power. Now I can no longer say that the second coefficient is going to be 4 choose 1. And the reason is that this 2 gets squared and cubed and quartered also. In other words, if I were to expand 2x minus y squared, okay? Does this look very familiar with what things you're doing right now?
Yeah. Well, yeah.
Or am I getting ahead? Am I getting ahead of you?
No, I think this is fine.
Okay, this feels to me like the only way I can explain it.
Okay, yeah.
Okay, and so let's expand 2x minus y squared. Well, the first coefficient is going to be what? 4 choose 0. But that's not the full coefficient because a is 2x. So it's 2x quantity to the 4th power.
Okay.
Notice what that makes the coefficient. The coefficient was 1, but now the coefficient is 2 to the 4th power, or 16.
Okay.
Okay? In other words, you have to substitute 2x for a and y squared for b. So let's go one more term. So the next term is 4 choose 1, and then it's 2x to the 3rd power, and then in place of b, it's y squared. Wherever I see b, I'm going to substitute y squared. Okay? Let's go one more term. 4 choose 2, 2x squared, but now it's y squared squared. You with me?
Okay. Yeah.
And notice what this does to our coefficients. Our coefficients that we could have gotten off of Pascal's triangle, off the 5th row, in other words, when it was a plus b, these were our 5 coefficients for the 5 terms. But that is no longer true because now we've got a 2 that's being taken to the 4th power. So this coefficient, which would have been 1 if it was a plus b to the 4th, is now 32. This coefficient, which would have been 4 based on that, well, now it's 4 times 8, so that's 32.
Okay.
And so forth and so on. So when you are expanding a binomial that is made up of more complicated terms like this, 2x minus y squared, you can still base it on that and the known expansion of a plus b to the nth. So it's worth memorizing that because you can do anything if you know that. I mean, you can expand any binomial. It doesn't even have to be linear. Notice that's a quadratic.
And can you just go back down to like the 32 thing again? Like,
Yeah.
a little confused.
Yes. Okay. This part of the number is what?
So when
4 choose 0 is what?
Is that is 0 or sorry 1.
That's 1. And
Yeah.
2x to the 4th power is what?
16.
Oh, sorry. Yeah, I'm sorry. I wrote 32. No wonder you were confused. 16 is 2 to the 4th power.
Okay.
So the very first term is going to be 16x to the 4th.
Okay.
Now,
So you just,
yeah, and this 32 was correct.
okay. So you just multiply the coefficient by a or b to get the coefficient, or you multiply the and choose whatever 0, 1, or 2, and then by the coefficient of a or b to get c.
Well, what you need to do is you need to let 2x in parentheses be substituted wherever we would normally write a.
Yeah.
Okay? Normally this would be just a. And this would be, I'm sorry, a to the 4th, and then a cubed times b, and so forth. But in our case, it's 2x, and always put that in parentheses, because if you leave these parentheses off, it's completely different. Then the 4 doesn't apply to the 2. So it's very important to put them in parentheses, but yeah, 2x to the 4th power is 16x to the 4th. And you're correct. You then multiply that by that coefficient, which is n choose r, with r starting at 0 and counting up to n. That's the way to describe r. When you said, what is r? That's what r is. R starts at 0 and counts up until it gets to n. So we go from 4 choose 0 up to 4 choose 4 as the last term.
So wouldn't r always be just 1?
No. Notice that r here is 0, r is 1, r is 2, next term r would be 3, up to 4.
Oh, so you mean, okay, I thought r was like the rate that it changed at. But okay.
No, well, I don't know what the, how they describe r. I haven't read this chapter recently, but in effect, r is a counter.
Okay.
And it counts from 0 to n.
Okay.
I think that's all you really need to know is about r, is that it counts from 0 to n.
Okay.
Okay. Do you have a specific problem that maybe we can do now? Now that we've had the class on the binomial expansion.
Let's see.
I want to leave it up there because it is a bit of a brute to memorize, but not really. If you notice the pattern of it, then it's actually pretty easy to memorize as long as you understand that r starts from 0 and counts up to n. Notice the very last term has b to the nth instead of b to the r.
So this problem, let's see. So this one is just wants you to find the coefficient of x to the 10th in the expansion of 3 plus 2x squared, and all that.
Like that?
Yeah.
Okay. So, which term do they want?
The 10th term, x to the 10th.
Okay. The 10th term. Alright, so the 10th term is going to have a coefficient of what? 10 choose what?
It just wants you to find the coefficient of the 10th term, but...
Okay, so we need to, first of all, this is going to have 11 terms in it. Notice that when you expand, when you take a plus b to the squared, you get 3 terms. When you take a plus b to the 4th, you get 5 terms. So if we take 3 plus 2x squared to the 10th, we're going to get 11 terms. So we want the 10th term. Well, this is what on the 10th term?
Well, that would be 9.
Yes, 10 choose 9. Okay. And what else are we going to have with it? We're going to have the first 3 is going to be to what power? Let's see here. It's always to the same power as r, so it's to the 9th. notice that up here when we did a plus b to the fourth, oh no, I'm wrong there. Hold on, let me think for a moment here. That term on the 10th term is 3 to the n minus r is the second to last term. So it's 3 to the 1. 10 minus 9 is the exponent on the second to last term. In other words, it would be, notice the exponent on the a of the second to last term up here. It's 1. And the exponent on the a term of the last term is 0. That's why it's not there. Okay, well, we're talking about the second to last term. So it's 3 to the 10 minus 9 times, you sure there's 2x's in parentheses like this?
Well, yeah, it is.
Okay, so that's 4x squared. Okay, so I'm going to stick in 4x squared for my b term.
Let's see. No, never mind.
It's not in parentheses. Okay, so it's like this.
Yeah.
So I'm going to stick in 2x squared for b. Okay, well, on my 10th term, 2x squared, now I have to put it in parentheses since I'm substituting it for b, and the exponent is r. Remember, this is my second to last term as r gets to within 1 of n. In other words, in this case, the second to last term is where r is 9. So the coefficient is 10 choose 9. The first term that would be a is 3 to the 1 power, which is correct. The second term, which is b, is going to be to the 9th power because it's to the r. Now, the very last term would be 10 choose 10. There is no 3, or 3 to the 0th power. And finally, 2x squared to the 10th. Okay? So we wanted the 10th term right there. So let's figure out what that coefficient is. First of all, what is 10 choose 9?
Oh, wait, sorry, say that one more time and cut out.
We're trying to figure out the coefficient of the 10th term, which is the term I have circled. So what is 10 choose 9?
That is just 10.
Yeah. What is 3 to the 10 minus 1? That's 3. And what is 2x squared to the 9th power? That's 2 to the 9th, right? There's your coefficient, 30 times 2 to the 9th, which I believe is 512. So your coefficient would be 15,360. That should be the answer, I think. Yeah, do you have the answer?
Yeah.
2 to the 5th is 32, 2 to the 6th is 64, 7th is 128, 8th is 256, yeah, 9th is 512.
And well, they phrase it as 10 choose 5 times 3 to the 5th.
That's the 6th term. That's the 6th term. If you start with a 10 choose 5, that is the 6th term of the result. You see why? In other words, you're always talking about, this is R, which is the 9th term that results. Notice that this was the, excuse me, it's R plus 1. Sorry. In the first case, R is 0, but it's the first term. So you have to add 1 to R. So we wanted the 10th term, so R is 1 less than that, so R is 9, so it's this number, choose 9. Did they give an answer for the 10th term of this sequence? For the coefficient?
That's what they say, the 10 choose 5 times 3 to the 5th times 2 to the 5th.
Well, hold on. That might be the same number as what we have here. They just might have done it differently. So they got it as 10 choose 5. What else do they have? 3 to the...
3 to the 5th.
Okay.
2 to the 5th.
Times 2 to the 5th? That might be the same number. Let's see. 10 choose 5 is 10 factorial over 5 factorial times 5 factorial. I'll tell you what. Let me feed that into Wolfram Alpha. I bet it is the same number. Ten factorial, oh boy, that might be hard for me to put into this. Maybe not. Let's see. 10, choose 5, is it going to recognize that? Times 3 to the 5th times 2 to the 5th. May not get my C. No, it didn't. Let me. Oh man, I wonder what I have to put in there. Would it recognize that perhaps? Yeah, I think it did. No, it didn't. Wow. Can you do it on your calculator?
Yeah.
Do that on your calculator. Yeah, that's right. I should be able to do it on my calculator, but gosh, I don't think I've ever done combinations on my calculator. I'm not sure I know exactly how to do it. If you know exactly where it's at, go ahead and come up with a number.
Alright. 10 choose 5. I got 252.
For 10 choose 5, okay. So now multiply that by 3 to the 5th and that by 2 to the 5th. Boy, that's going to be a big number. It's going to be a lot bigger than the number I got. How did they get such a big number?
Yeah, I got like 1,959,000.
Yeah, but see, the fact that they said it was 10 choose 5, that's not the 10th term. That's the 6th term. And these middle terms always have the biggest, in other words, if you look at Pascal's triangle, the big coefficients are always in the middle. Well, in other words, as you go down, in other words, as you expand something bigger, well, these coefficients are the biggest, always in the middle. Well, in this one, they wanted the 10th term, which is the second to last term. And the result that you gave me would indicate that they're looking in the middle. Because if it's 10 choose 5, that's the 6th term. Remember, 10 choose 9 was the 10th term.
Yeah, it might be a mistake because though. I checked multiple times and it just says find the coefficient of x to the 10th in the expansion of 3 plus 2x squared to the 10th.
And I wrote this exactly right. 3 plus 2x squared. It's not the quantity 3 plus 2x all squared?
No, that's right.
Okay.
But you have.
I feel like I did it correctly. I really do. I don't understand why the discrepancy. Here, let's try something. Let's try doing this on Wolfram Alpha and see what we get. 3 quantity 3 plus 2x squared all raised to the 10th power. Expanded format. Aha, 15360. See that number? That's always the same as the second to last number. In other words, the last number is always the first. 10,000. Remember, the first column of Pascal's triangle is always the same as the last column. And the second is the same as the second to last. So the number you were looking at would be the sixth term, which is this term right here, which is 1,088,640. But if they showed the whole thing, they would One, two, three, 4, 5, 6, 7, 8, 9, 10, 11. They're showing the 10th term as 393,660. My logic is off. In other words, the fact that that first thing is a 3 must matter. Huh. I'm a little confused now. Why this coefficient is not the same as that coefficient. Well, I'm not sure. Probably don't want to waste any more time on this, is my guess. I might have to, I don't know. Shall we go to another problem? You got another one similar to that? Or, in other words, where I may be getting screwed up there is the fact that it's x squared.
Well, I'm pretty sure the book just messed up the answer though, because
yeah, their answer didn't agree with Wolfram Alpha either. It looked to me like the book's answer is the 5th or 6th term.
Well, yeah, and they specify the 10th term. Yeah, and then there was like 10 choose 5, I think.
Right, but see, that puzzles me how they got that, because that doesn't match the binomial theorem. In other words, yeah, the binomial theorem, if you look at it, that's it. This first row along with this term here. And what I have circled is the second to last term, and this is the last term. So it's the second to last term that we want when they want the 10th term. And that's 10 choose 9. So I'm not sure where they're coming up with that 10 choose 5.
I don't know.
And the 3 to the 5th would match the middle part of that answer, as well as 2 to the 5th.
Really
what's that?
Really fast, can you just like go over again why the 10th term is 10 choose 9?
Yeah.
Like,
What's the first term? First term is n, it's n choose 0. The second term is n choose 1. So the term is always one less or one more than the r. That's the second term, but r is 1. That's the second to last term, and r is 1 less than n in this term. That's why this is written as kind of a screwy looking sum. In other words, you don't see very many sums that have dot, 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 something, and then more plus. Well, that's because that's the next to last term, and this is the last term.
Okay.
So when they ask for the 10th term of an 11-term sequence or series, they're asking for that one. So it would have to be 10 choose 9 times 3 to the 1 power times 2x squared to the 9th power. So that's where I got my 2 to the 9th and 3 to the 1. And they ended up with 3 to the 5th, 2 to the 5th. Well, that's in the middle. That is like the 6th term.
Yeah.
It would appear that that's the 6th term. In fact, it is, as far as the coefficients go. That's 3 to the 10 minus 5, or 10 choose 5, and that comes at the 6th term. So the answer they gave you should be the 6th term, and I think it was. When we looked on Wolfram Alpha, that 6th term had a coefficient of 1,959,000. Was that what you got?
Yeah, I believe so.
Okay. Ah, look at what that is. Now I'm understanding it. Look at what the x power is on my screen. It's x to the 10th. So they were saying, what is the coefficient of the x to the 10th term? Not the 10th term. That's the 6th term in the series. But it's the term that has 10 as the exponent on x. Okay. Now I'm with it. Now I get it.
Wait, so how do you know?
Okay. How do we know what that would be? Well, let's see. When we expanded it out, I can tell that I need r to be 5. Because it's going to multiply by the x squared, and it'll be 10 when r is 5. So that's what they mean. They mean the coefficient of the x to the 10th power, and that's going to come when r is 5, because it's going to be 5, it's going to be 2x squared to the 5th, which gives you x to the 10th. So that's what's going on. Now I get it.
Okay.
There was a huge, I'm completely cleared up now, and I was a little in the dark too.
Yeah.
But the 10th term is not going to be the same as the term that has x to the 10th power, because you can see the very first term has x squared. So the term that has x to the 10th is going to be the 6th term of the series.
Yeah.
Where r is 5. And that's how they got 10 choose 5, and how that's r, and that's, one of these is 10 minus 5, and the other is just 5.
Okay.
Okay? All right. Well, good. I'm glad we got that straightened out. Boy, it was funny, too, because it was just accidental. I looked at that 6th term, and I saw x to the 10th, and then I realized what they're talking about.
Yeah, okay.
Okay, well, good. I'm glad Wolfram Alpha helped. All right. I have a 7 o'clock, so I have just a couple minutes. If you have any final questions?
Let's see. There's one more. Well, I think those are all
Well, I don't think I quite have time to do a whole problem. Look, I can get started on it in a minute or so. Let's write it out and we'll see what it looks like.
All right. X cubed in the expansion of 2x squared minus 3 over x.
Hold on a second. Let me erase this so I have room to write. I don't want to erase this at the top here, because until you have it completely memorized, it's impossible to tell. So I'm sorry. What is the term to be expanded?
Well, x third or x cubed is the expansion of
Okay.
2x squared minus 3 over x.
Minus 3 over x?
Yeah.
Really? Minus 3 over? Okay, yeah, no, that'll work. Okay.
And to the
6?
everything.
6 or 5? Okay.
6. Yeah, that's right.
Okay. And they want the coefficient of the x cubed term,
Yeah.
which we can see is not going to be the third term. Okay. So, don't think I'm going to have time to get very far on this, but let's write the first few terms. What goes here? In another.
6, 0.
Yeah. And then instead of a to the nth, it's
2x squared.
to the nth, to the 6th. Okay. And then the next term is, we'll put a plus there. This is 6, choose 1. 2x squared to the 5th minus 3 over x to the 1st.
Yeah.
So this exponent's going to count down. This exponent's going to count up. Find out at what point they're going to result in an x cubed. Notice that if I expanded this right now, it would be x to the 10th divided by x, so that would be x to the 9th.
Yeah.
Okay? So you're probably going to want to get down to something that looks like this. 2x squared to the squared and minus 3 over x squared. No, minus 3 over x to the 1. That would result in an x cubed term. So you kind of have to go into this series a little bit, in other words, do the next few terms and figure out at what point you're going to result in an x cubed. And then that's the coefficient you have to find. Okay?
All right.
All right, Sarah. I will talk to you next time. Sure. Bye-bye.